So now how to tell delta modulator that MCAP-T should increase the step size or it should decrease the step size. Here we want to increase the step size and here we want to decrease the step size. So this is done with this extra circuitry that we have in adaptive delta modulation. So now let us first consider that the slope overload is taking place and the output is continuous stream of logic 1. Now in this case we get a continuous 1 at the output side, and because of this you can see the output will be constant positive voltage, some positive voltage which represents logic 1s. Now this positive voltage is also given to RC circuit, and you can see that the capacitor will start charging due to this positive voltage. It will charge to some positive voltage with the upper plate being at positive polarity. So this increased voltage we see, the capacitor will keep on charging due to continuous ones which are occurring at the output side, is given to a squaring circuit. Squaring circuit will square the voltage and give it to the amplifier. Now if you can recall the delta modulation, this initial part is very much similar to what we already had in delta modulation. This SOT which is the ones and zeros at the output side, is given to an amplifier, and this amplifier, when the output is passed through the low pass filter, generates the MCAP-T, which is a step-like structure. Now earlier without this RC circuit we will get MCAP-T with constant step size. Now because of this RC and the squaring circuit, the squaring circuit will give you increased value of VC and it is given to the amplifier. So this, what will the output of squaring circuit will do? Output of squaring circuit will increase the gain of the amplifier. It will control amplifier gain. So if the squaring circuit output increases, the control signal that goes to amplifier increases and amplifier gain will increase. If the amplifier gain increases, then MCAP-T will be available with greater step size. Now how squaring circuit output will increase? It will increase if the capacitor is continuously charging, and that will happen when there is a continuous stream of ones on the output side, which indicates the slope overload error. The slope overload error also takes place when the M of t is decreasing at very fast rate. In this case the output will be continuous stream of zeros. Zeros will be represented with negative voltage, and hence this time capacitor will charge, but it will charge to the negative voltage. So the new polarity of voltage will be minus on the upper plate and plus on the lower plate, and because of this we are putting squaring circuit here. Even when the voltage across capacitor is with opposite polarity, continuous stream of logic 0 still correspond to the slope overload, and I have to still increase the step size of MCAP-T. And for this reason my input to the amplifier should still increase. Now if you are giving negative voltage as the control signal, then the gain of the amplifier will reduce, but negative voltage is negative only across capacitor. When it passes through squaring circuit, as the name suggests, it is going to square the input signal. Whether it is positive or negative, the output of squaring circuit will be positive voltage. So even when you have a continuous stream of logic 0, the voltage across capacitor will be negative, no doubt, but after passing through squaring circuit the voltage will be positive, which is given to the amplifier, and amplifier gain will increase in both these cases. In a case where granular noise is taking place, the output will be continuous occurrence of alternate ones and zeros. So this means you have a positive pulse coming and then negative pulse coming, positive pulse, negative pulse. Now if you give such type of signal to capacitor, the average value of positive and negative pulses will always be 0. So average voltage will be 0. That means capacitor will charge, discharge, and hence the voltage VC across capacitor in this case will be 0. The average voltage will be 0. Now if that is the case, the output of the squaring circuit will also be 0, and this will indicate that the amplifier has to reduce the gain. With 0 control input to the amplifier, the gain of amplifier will be reduced greatly, and that's how the MCAP-T step size will reduce and the granular noise will be avoided. So this whole thing will take place in closed feedback loop in proper controlled manner, and whenever there is slope overload or granular noise, it will be controlled or avoided with varying step size of MCAP-T. So that's how adaptive delta modulation overcomes slope overload and granular noise by point number one, first detecting when slope overload and granular noise occurs, and point number two, with this extra circuitry, it controls the step size of MCAPT. It increases the step size in slope overload error and decreases the step size in granular noise.